Hello and welcome back to Miles Maths. Today we're going to be looking at range and domain part 2. I'm going to be looking to begin with at quadratic functions. Then we're going to go on to look at trigonometry or trigonometrical functions, but only very briefly. So this follows on from range and domain part 1, which you should have looked at if you're here. And we should know what range and domain are. Domain is the values that we can input into a function. Range is the range of values that will come out of that function. So let's begin by considering a quadratic function and seeing how this differs from a linear function or some of the simpler functions we looked at in the last video. To begin with, what we're going to look at is we're going to look at f of x equals x squared minus 10x plus 4. And we're going to assume a domain of 1 to 11 inclusive. So 1 is less than or equal to x is less than or equal to 11. Well, as we talked about in the last video, the first way to approach this is to look at f of 1 and to say, okay, well, f of 1 would be 1 squared minus 10 times 1 plus 4. And this is clearly 1 minus 10 plus 4, which is equal to minus 5. We would then look at f of 11, and we would say this was 11 squared minus 10 times 11 plus 4. So this, of course, is 121 minus 110 plus 4, which is equal to 15. Now, it would be tempting to say that the range would be minus 5 to 15. However, as we're about to see, that would be incorrect. What we can do is we can say, well, we're not quite sure when the minimum point of this curve is. We know this is a quadratic curve, therefore we know it has that beautiful shape, and we know there's a minimum point down here. And we don't know that this is the minimum point, so we really ought to check that. And of course, the way we check that is by completing the square. So if I look at f of x is x squared minus 10x plus 4, I can complete the square or put it into completed square form in the way I normally would. I would take that minus 10 and I would divide it by 2. This would give me x minus 5 all squared plus 4. And of course I now have this correction I have to make, which is minus 5 squared. Minus 5 all squared, which is 25, and I have to take that away. So this will give me, in completed square form, x minus 5 all squared minus 21. Now this means the turning point of this particular quadratic is going to be 5, which comes from this minus 5, and I change the sign, and minus 21. I don't change the sign on this one. So now I can look at the three values I have. I have minus 5, I have 15, I have minus 21, and I can get a reasonable sketch actually of this function. So if we knock up a set of axes quite quickly here. And you'll remember, sketching graphs should take seconds. It's not a very long process. I know the minimum point is 5 minus 21. So 5 minus 21 might be down here somewhere. I might have, I've got the point 1, which is here. And at 1, I know the value is minus 5. So we have a value in here somewhere. 1 minus 5, that bracket a bit bigger, and I have a value at 11 up here, and the value at 11, it turns out, is 15. So that's somewhere up here. And I can see also that this thing has a y-intercept of 4. So I know this curve kind of comes down like this. It goes through 4. It carries on down a nice smooth curve through here and back up here. And I can actually know there is an intercept there at 4. It's this solid part of the curve I'm actually really interested in, though, because this is the piece that actually exists within our domain. In other words, between 1 and 11. And therefore I'm interested in the y values, and I'm interested in the range of y values between these 2 points. And what I can see is I have a point here and I have a point here, and I'm really just looking at what is the range of these points. Well, for a start off, at 11 I can see there's a less than or equal to sign, so my value here could be 15. It isn't less than 11, it's less than or equal to 11. So this value could be 15. So if I think about this as being a number line, I'd be colouring the dot in at that point. At 5 down to minus 21, missed the bracket off there, look. I can see that actually when x is 5, y is minus 21. And hence this would also be a coloured in dot. And you're really looking at the inequality that exists along that red line. So I can see this would be between minus 21 and 15. So my range is minus 21 is less than or equal to f of x is less than or equal to 15. We can see this point isn't the lowest point in the function, it's actually this minimum point. And this is what I have to continue to look at when I do these quadratics. So let's try a second example. So we'll call this EG2. And this time we'll use f of x is equal to x squared minus 2x plus 12. Okay. And what I'm going to give you an opportunity to do is to stop this video at this point. We'll just talk about what you're going to do. For a start off, we haven't got a domain. Let's give it a domain. Minus 1 is less than x is less than 7. Let's give it a domain. Now, what we're going to do is we're going to consider f of minus 1. We're going to consider f of 7. And then we're going to go and find the turning point for this. So we need to know f of minus 1. We need to know f of 7. We need to complete the square and find the turning point. When we've found the turning point, we need to draw some form of sketch diagram. And then we need to look at the minimum and maximum y values. And that is going to give us our range. Okay, so following that procedure, f of minus 1, f of 7, find the turning point, draw a sketch diagram, and then identify the range. Stop the video here, go and have a go, and come back in a second. Okay, let's assume you're back then, and we'll have a go at this one. So the first thing to do is to try f of minus 1. Well, f of minus 1 would be minus 1 all squared minus 2 times minus 1 plus 12. This is going to be equal to 1 plus 2 plus 12, which is 15. We're then going to try f of 7. f of 7 is going to be 7 squared minus 2 times 7 plus 12. 7 squared is 49. Minus 14 plus 12, that would give me 47. So I've got my two values in here that I'm going to need. I'm now going to complete the square to find the minimum point. So f of x equals x squared minus 2x plus 12. We're going to halve that minus 2 and get x minus 1 all squared plus 12, except we now have to put our correction on. Minus 1 squared is 1. Take it away, that's minus 1. This in completed square form then will give us x minus 1 all squared. 12 minus 1 is 11. This is the function in completed square form. I can therefore say that, therefore, the turning point has got to be 1, 11. And I can have a look at my values. And so these are the things we're going to be using. I know my y-intercept up here. My y-intercept in the original equation was 12. So I should be able to draw myself a sketch. Now, interestingly, with this one, I need to go into the negatives. So I'm going to draw my axes a little bit differently. I'm just going to think about my axes a little bit. I'm going to draw my axes a bit more like that. I'm going to think about what happens at minus 1. Well, at minus 1, I've got 15. So perhaps here, I could say that I have minus 1, 15 is this point here. At 7, which is somewhere up here, I have the point 47. So this will be this point 7, 47. At the turning point, I'll have 1, which will be 11. So that will be somewhere just down there. I'll have the point 1, 11. I can then, I know my y-intercept is at 12. So this is going to look like something like this. The curve comes down like this, and then I'm interested in this piece of the curve. And then the curve goes off in that direction. Obviously, this is the piece of the curve I'm interested in because I have the domain. Sorry, I have the domain here from minus 1 up to 7. There's my domain. So I can now look at my range and I can say, well, this point here, this would be at 11, and it would include 11. So a nice coloured in dot. I can look at this one and say, okay, across to here, I'd have, it's not coming out very well. I would have 47, and interestingly, x is less than 7. So I'm right up to 47, but I'm not quite there, and that would be an open circle because it's a less than sign. And I'm just looking for this red line in between, so I can now say that my range must be equal to, well, the minimum value would be 11. I don't know why I've put a bracket in there. So 11 is less than f of x, is less than or equal to 47. However, at this point, it's a coloured in circle. It could actually be equal to 11. So my range is simply 11 is less than or equal to f of x is less than 47. So this is quite a substantial piece of procedural mathematics. If we go on to look at a slightly more difficult example, then finally, and then we'll move on perhaps. So EG3. EG3, we're just going to consider something where we have f of x is equal to a quadratic where the coefficient of x is not 1. But a similar sort of process occurs. So we're going to look at f of x equals 2x squared minus 8x plus 17. Now we'll give this a domain. So the domain here will be that minus 3 is less than x, which is less than 4. And we're looking for a range. You've obviously got to make sure you know how to complete the square on a quadratic where the coefficient of x squared isn't equal to 1. There is a previous video which you can look at if you need to look at that. But we do a part factorization in here. And we just look at this part of the formula. and we remove a 2 from that. We leave the 17 alone. We would then complete the square on this section, so 2 x minus 2 all squared, and obviously all of this has been multiplied by 2. It's all in this big square bracket plus 17. I have to then put my correction on. Minus 2 all squared is 4, doubled is 8, and I have to take it away. So I have to take away 8 at this point. This gives me a completed square form of 2 x minus 2 all squared, and 17 take away 8 is 9. So I can say, therefore, the turning point must be 2, 9. And notice I've changed the sign of the minus 2 into a plus 2. So this is one piece of information I need to know. Notice I've done this in a different order. I've completed the square first this time, whereas in the previous examples we actually worked out the f of the two ends of the domain. Doesn't really matter which order you do it in. So at this point we're going to have f of minus 3, because we have to do all of these steps. It doesn't matter which order we do them in at this point in time, because we've got to get to the sketch. But f of minus 3 would be 2 times minus 3 all squared minus 8 times minus 3 plus 17. And that is 2 times 9 plus 24 plus 17. So we have 18 plus 24, 59. I think. And then we would have f of 4, and f of 4 would be 2 times 4 squared minus 8 times 4 plus 17. So this is 16, 32 minus 32 plus 17. This gives us 17. So we can look at the 3 vital parts of our puzzle right now. We certainly have a highest value here of 59. We have a lowest value here of 9. Now, we're just then going to do a sketch. We're going to do this properly. There are potentially shortcuts to this, but we're not going to take them. Where were we? 9:59. Okay. So here's my sketch. So we're going to look at this really thoroughly. At minus 3, I end up at 59. So I end up here. I end up right up here. Minus 3, 59. When x is 4, I end up at 17. So I'll go about here. So this is when x is 4, and we end up at about 17. Oops. And then the turning point is at 2, at 9, which is somewhere down here. And I can draw my quadratic in. It clearly comes down here. I get a lovely smooth curve through the minimum point, back up the other side. And it's only this solid part of the curve I'm interested in, because I'm told the domain up front is between minus 3 and 4. Therefore, when I'm looking for my range, I'm looking for, well, where's the highest value on here? It's here. Is this included within the value? Minus 3. Minus 3 is less than x. No, it's a not included value, so it's just going to be an open circle. 2, 9, or 2, 9. We can see it actually goes through the point 2. Clearly, we're allowing the point 2 because 2 is between minus 3 and 4. Therefore, this is an allowed point. It can be equal to 2, and therefore f of x could be equal to 9. So clearly, this has got to be a coloured in circle, and all we're doing is taking the values between these 2 points to be my range. So I can say, therefore, range is equal to 9 is less than or equal to f of x is less than 59. And that is how we find the range of a function given its domain when the function is quadratic and it's just some random quadratic. Now, a very similar procedure applies when we look at trigonometrical functions. So if we do this with a trig function, and we're only going to do one example of this, but they're very, very similar. And if you can do this, you can move the method over to trig functions quite easily. And that is, we're going to look at f of x equals sine x for x. For 30 is less than x is less than 210. And we want to know the range of this function. Well, the way to do this is to provide yourself with a little sketch of what it looks like. And we clearly know what sine x looks like. So let's, without drawing anything, we're going to be in trouble. So we're going to make sure we draw something. But we're not going to plot any values. We know what sine x looks like. It looks like something like this. So there's y equals sine x, or f of x equals sine x if you prefer. However, it's interesting to note that we're not looking at the entire graph. We're only looking at a very small part of it. We're looking at the parts of the graph between 30, which is about here, and 210, which is somewhere around here, let's say. And we should know some values for this. So at 30, we should know a value for y. You should know that that's a half, 0.5. At 210, you may or you may not know that the value would be minus a half. And so now what we want to do is we want to look at the range of the function. Well, clearly the maximum of the function between these two values would not be at a half, it would actually be here. Now, would this be an included value? When I get to 90, is sine x exactly 1? Well, yes it is. So this is an included value, therefore I can colour in the circle. At 210, I've smudged that a bit. It's less than 210. Is that an included value? No, it's not. So I can leave that as an open circle. And I can fill in my line, and therefore I can say that therefore my range must be minus a half is less than f of x is less than or equal to 1. And this would be the range of my function. Make sure that looks like f of x. And that's range and domain of quadratics and trig functions. Thank you for visiting Miles Maths. Please come again.